France rushes radar SAMP shield Ukraine. It is Monday, February 9th, 2026. The air defense landscape in Europe is shifting, and it is shifting fast. If you care about freedom, justice, and the defense of sovereignty, you really need to hear what is happening in Kiev right now.
Cool. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. Join me in the latest program by Defense Report for the latest in global defense news, military technology, and strategic developments. And today, we're going to cover, well, a critical situation developing on the Eastern Front. We have reports of a significant gap opening up in Ukraine's air shield, a frantic mission by the French government to plug it, and the arrival of a new generation of technology that just changes the math of the entire war. I'm looking at these reports, and frankly, the urgency is just jumping off the page. We have the French Minister of the Armed Forces, Catherine Vautrin, personally on the ground in Kiev. We have broken hardware, and then there's this new 10-year pact that seems to be rewriting how Europe defends itself. But let's start with the immediate news. Why is the French minister in Kiev right now?
Is this, just a photo op, or is something actually breaking?
It is definitely not just a photo op. This is a maintenance crisis. Minister Vautrin is there because the Arabelle radars, the absolute heart of the SAMP air defense systems protecting Ukraine, are starting to fail.
That does not sound good. These are the systems protecting cities from ballistic missiles.
Exactly. And they aren't failing because they're bad tech. They're failing because of, well, physics. You have to remember, these units have been running nonstop 24/7 since mid-2023.
Wow.
They are operating in high-intensity combat, dealing with massive Russian shelling, extreme temperature shifts, between Ukrainian winters and summers, and just constant electronic warfare pressure.
I guess we don't think about that often. We see the videos of the interceptions, but we don't think about the machine just humming in the background for 3 years straight.
Right. Even the best engineering has a shelf life when you run it at redline for that long.
Yeah.
The Arabelle radar is, in many ways, a mechanical system. It has moving parts. It generates massive heat. Eventually, components just wear out. And right now, that wear and tear has reached a critical point.
So if they need repairs, you usually take them offline. But if you take the radar offline in Kyiv or Odessa,
you leave a massive hole in the sky. And in 2026, with the sheer volume of fire Russia is using, that's a death sentence for civilians. The SAMP is currently the only European-made system in Ukraine capable of intercepting ballistic missiles, things like the Iskander or even the Kinzhal.
So if that radar goes dark, even for a week,
those missiles get through. It's that simple.
So what's the plan? They can't just fix it on the fly.
No, it's far too complex for that. So what France is doing is executing a hot swap. Minister Vautrin confirmed this during her visit. They aren't just taking the radar away. They are rushing a replacement radar to Ukraine to be plugged in immediately.
A spare radar. I assume these things were built to order. Did they just have them sitting in a warehouse somewhere in Paris?
Sitting around might be the wrong phrase, but this really highlights a massive shift in the industrial base. Companies like Thales and MBDA have been on a total war footing for the last 2 years. Thales, for instance, has tripled their radar production.
Tripled it.
They've been building what they call a float, a strategic reserve of equipment specifically for this exact scenario. They knew the attrition was coming.
That's actually impressive foresight. It feels like for so long, the narrative was that Europe was, running out of ammo. This suggests they're actually managing the logistics pretty tightly.
They are catching up. It's a logistical nightmare, of course, to move a radar that size across a continent in secret and then perform a swap during a war, but it keeps that shield intact.
Okay, so that's the immediate Band-Aid, if you can even call a multi-million-dollar radar a Band-Aid. But looking at the rest of these documents, the bigger story isn't about repairing the old stuff. It's about this new generation hardware, the SAMP-NG.
This is the leap. The repair keeps the lights on. The NG, it turns the lights into a laser beam.
I was looking through the specs you sent over, and some of these numbers, they look like typos. The old radar tracks, about 100 targets?
Correct. The Arabelle can track about 100 targets simultaneously and sees out to roughly 100 kilometers. That was absolutely cutting edge 15 years ago.
And the new one?
The new one is the Thales Groundfire 300. It tracks 1,000 targets simultaneously, and it pushes the detection range out to 400 kilometers.
1,000 targets. Why on earth would you need to track 1,000 targets? That just sounds like overkill.
It would be overkill if we were fighting a war in 1990, but in 2026, it's barely enough. We are seeing saturation attacks now. Russia isn't just firing 1 or 2 missiles.
Right.
They are launching swarms, mixed packages of 500 or more aerial threats in a single night. You've got cheap drones, cruise missiles, decoys, and ballistic missiles all coming in at once.
I see. So the old radar would just get confused, a kind of system overload.
Exactly. It runs out of computing power and signal processing channels. It might see the 101st missile, but it can't track it effectively because it's completely maxed out. The Groundfire 300 is designed specifically for that swarm scenario. It doesn't blink.
Now, I saw a technical term here regarding how this radar works, gallium nitride. The report makes a big deal out of it, but to me, it sounds like something from chemistry class. Why is this so important?
It is chemistry, but it's game-changing chemistry. Think of the old radar chips like a standard silicon computer chip, the kind in your laptop. If you push too much power through silicon, it gets hot.
Okay.
Too hot and it melts. So there's a hard limit to how much energy you can pump out.
So it's a heat limit.
Right. Gallium nitride, or GaN, has a much wider band gap.
Bad gap.
In simple terms, it can handle vastly higher voltages and temperatures without frying. It's like swapping a garden hose for a fire hose, but keeping the nozzle the same size. You can just pump way more energy through the system.
And that gives you the range.
That's how they get that 400-kilometer range and the ability to spot tiny drones without needing a radar dish the size of a stadium. It's smaller, mobile, but incredibly powerful.
That makes sense. More power, less heat, better vision. But a radar just sees the threat. You still have to hit it. And this is where I got a little lost in the acronyms. The report mentions the Aster 30 Block 1NT and something called PIF.
Ah, yes, the PIF.
I mean, come on. That sounds like a cartoon sound effect. PIF. PAF. Is that a real term?
It is very real, and it is very French. It stands for Pilotage en Force and Pilotage Aerodynamique Fort.
Okay, my French is a little rusty. What does that actually mean for the missile?
It's a dual steering system. Most missiles steer like airplanes. They have fins on the tail that move to change the airflow. That's the PAF, part aerodynamic steering. But the problem is, at very high altitudes where ballistic missiles fly, the air is really thin.
Right, there's nothing to push against.
Yep. Exactly. So the fins don't work very well. The missile becomes sluggish. That's where PIF comes in. The Aster missile has a set of lateral gas jet's tiny thrusters right at its center of gravity.
Like a spaceship maneuvering in orbit.
Precisely. It can fire a jet of gas to shove the missile sideways instantly without waiting for the fins to catch the air. This allows the missile to pull 62 G-turns.
62 Gs. A human pilot passes out at, what, 9 Gs?
A human is not surviving 62 Gs. This missile doesn't just fly, it violently dances. It lets it match the maneuvers of hypersonic missiles like the Kinzhal or ballistic missiles that try to dodge at the last second. It corrects its path instantly.
That is just wild engineering. But being able to move fast is one thing. Being able to see where you're going is another. I saw one more term. Ka-band seeker?
Right, and that's on the missile itself. The NT in Block 1 NT stands for new technology. The seeker is the eye of the missile. Ka-band is a very high frequency.
Its frequency means higher resolution.
Exactly. Think of the old seekers as seeing in standard definition. The Ka-band is like 4K. When you are trying to achieve a hit-to-kill intercept, this is absolutely vital.
And hit to kill means physically ramming the target, right? Not just exploding near it.
Yes. For a cruise missile, you can get close and use a blast fragmentation warhead like a shotgun. But a ballistic missile is hardened. It's a falling telephone pole made of metal and explosives. A shotgun blast might just dent it.
So you have to actually hit it.
You need to hit it directly, bullet on bullet, to transfer all that kinetic energy and just shatter it. And doing that when both objects are moving at Mach 5, well, you need that Ka-band seeker to see the target with perfect clarity in the final milliseconds.
Okay, so we have the super radar and the dancing missile. This all sounds incredible, but usually when we hear about this kind of tech, it's followed by coming in 2035. The timeline here seems aggressive.
It is incredibly aggressive. And this brings us to the strategic level. That pact signed by Zelensky and Macron back in November 2025. This wasn't just a handshake. It was a contract for 8 full systems.
8 systems. And I read that the French configuration is heavier than the Italian one.
That's right. The Italian batteries usually have 4 launchers. The French setup for Ukraine is spec'd with 6 launchers per battery. That is a massive amount of firepower per unit.
And Macron said Ukraine gets priority.
He did. He confirmed that the first SAMP-T NG systems coming off the production line, which are becoming operational right now, early 2026, are being prioritized for Ukraine.
Wait, so the French military is waiting in line behind Ukraine?
In effect, yes. It's a bold political move. France is delaying its own modernization slightly to ensure Ukraine gets the tools it needs to survive right now. It signals that Paris sees the defense of Kyiv as the defense of Europe.
Which leads me to the money question. I mean, 8 of these systems. We have to be talking billions of euros. Ukraine is fighting a war. Their economy is battered. How are they paying for this?
This is where the geopolitics gets really fascinating. They are using a mix of mechanisms like the SAFE program, but the heavy lifting is being done by something called the ERA instruments.
ERA.
It refers to using the interest generated from frozen Russian assets.
Okay, I want to be clear on this. Are they taking Russian money and buying missiles with it?
Not the principal, that would be legally tricky, but billions of euros of Russian central bank assets are frozen in European banks. Those assets generate interest, hundreds of millions, even billions over time. The EU has decided that this windfall profit doesn't belong to Russia.
So they're skimming the interest.
They're skimming that interest and funneling it into the European peace facility to pay for this gear.
So in a roundabout way, the interest on Putin's savings account is buying the missiles that shoot down his army's rockets.
It's a poetic kind of justice, yes. And it solves the problem of donor fatigue. It's not French taxpayer money directly. It's money generated by the aggressor's frozen capital.
That's clever.
Yeah.
But there's another layer here, strategic autonomy. I keep seeing this phrase in the French press. What does it actually mean for Ukraine on the ground?
It means moving away from begging. For years, Ukraine has lived hand to mouth, just waiting for the next aid package. Strategic autonomy means building the capability to sustain yourself. As part of this deal, Thales isn't just shipping crates. They've established a joint venture inside Ukraine.
So they're building the tech locally.
They're starting with maintenance and repair, but the goal is local production. It means if a radar breaks, you don't have to ship it to Poland or France. You fix it in Kyiv. Eventually, maybe you build the components in Dnipro. It turns Ukraine into a sovereign military power.
That feels like a huge shift. It's a long-term marriage, not a summer fling.
Exactly.
But let's play devil's advocate for a second. We've talked about the Ferrari of air defense, the SAM PTNG.
Yeah.
It's expensive, it's high-tech. But the Russians aren't just using high-tech missiles. I've been reading about these fiber optic drones.
That is the asymmetry problem. You cannot fire an Aster 30 missile, which costs millions, at a customized FPV drone that costs $500. You'll go bankrupt in a week.
And the Russians know this.
Of course. And these fiber optic drones you mentioned, they sound primitive, but they're brilliant. Usually a drone is controlled by radio waves, so you just jam the area with electronic noise and the drone crashes. But these drones trail a thin fiber optic cable behind them, sometimes for 10 or 20 kilometers.
A physical wire, like an old landline phone.
Exactly. And because the signal is traveling through a glass wire, it is completely immune to electronic warfare. You can jam all you want. That drone is going to keep coming.
That is terrifying. So what do you do?
You need a cheaper bullet. This is the other side of the innovation we are seeing. The report highlights companies like Frankenberg Technologies. They're testing the MKI missile.
And this is the low-cost solution.
Extremely low cost. We're talking about missiles built with 3D printed parts, off-the-shelf electronics, and yes, even wood for some structural components.
In a missile?
Why not? If it only needs to fly for a few minutes and hit a slow-moving drone, you don't need aerospace-grade titanium. You need something that costs less than the drone it's destroying.
It's all about the economics.
It's the cost-exchange ratio. The goal is to build a cheap interceptor to kill the cheap threats, so you can save the precious Aster 30s for the ballistic missiles.
It was like a layered cake.
Precisely. It's an integrated air defense network. At the bottom layer, you have these cheap Frankenberg missiles and anti-air guns. Then you have the Mirage 2005 jets, which are already active hunting the Shahed drones.
And then the radars.
You have the GM200 radars acting as gap fillers, seeing threats at 250 kilometers to warn the network. Then the SAM-TNG takes the high-altitude, high-value targets. And finally, the pact includes 100 Rafale F-4 fighters.
And these systems all talk to each other.
That is the cooperative engagement capability. The Rafale F-4 and the SAM-TNG are designed to share data instantly. The jet can see a target behind a mountain and tell the ground radar to fire. Or the ground radar can guide a missile launched by the jet. It creates a web that is much, much harder to break.
It sounds like they are trying to build a fortress. Not just patching holes, but constructing a legitimate Iron Dome for the whole of Ukraine.
That is the ambition. If you look at the timeline 2026 to 2030, the goal is that by the end of this decade, Ukraine will have one of the most sophisticated, battle-tested air defense networks on the planet.
It's a sobering reality that this is necessary, but it's also, I don't know, a hopeful sign of commitment. We aren't just seeing a repair mission. We are watching the construction of a new security reality in Europe.
And it's happening fast. The fact that we're talking about hot-swapping radars and deploying prototype tech in February 2026 shows a level of urgency and resolve from Paris that we haven't seen in decades. They are all in.
It's certainly a development we will be watching very closely as those first NG batteries arrive. You've been listening to Defense Report by Alex, where we analyze the latest in military strategy, global defense, and advanced weaponry. Subscribe to Defense Reports, your trusted source for timely, in-depth military and defense analysis. We'll see you next time. Keep supporting us so we can continue bringing you the latest developments from Ukraine and around the world.